Good morning, everybody. Thank you for joining us today. This is our first webinar of fall of 2025, and I'm very excited to introduce you to our panelists. We will be presenting Prima non Ultima, which is a Gomex Engineering retrofit. Just a reminder for everybody that this session is being recorded, and we will be publishing this to our YouTube channel and then sharing on social media. Now, I just want to start with a land acknowledgement. I'm joining here today from Treaty 6 in Edmonton, and just want to take time to show our gratitude and respect to First Nations who have inhabited and cared for these lands long before today. We're grateful for the millennia of stewardship that has taken care of trees to give shade, water and food to sustain us, and paths to connect us. We recognize the unceded traditional territories of many First Nations where we now live and work. So my name is Tim Wilson. I am the Executive Director of Retrofit Canada. Retrofit Canada is an open source nonprofit. We exist to collect information and knowledge and solutions about completed retrofits and then share that information with the world. We get some of this information from the case studies in our case study library, which is the largest platform in the country with deep retrofit case studies. We also have people like our co-founder, P.Eng and my board member, Lorrie Rand, who is here today with her other hat on with the Recover Initiative. They are doing work on projects, and that information is also really important to us as we develop a retrofit roadmap and just try to share helpful information to mobilize a workforce to get deep retrofits done at the scale that we need to meet our 2050 target to become net zero. So I also want to acknowledge our partners and funders. First, our founding partner, Sundance Housing Co-op, and as well as our funders, the National Resources Canada, Alberta's Smart, Sustainable, Resilient Infrastructure Association, and Alberta EcoTrust. And I also want to acknowledge our project partner, Southern Alberta Institute of Technology and the Green Building Technology Access Center. They are helping us find and publish case studies, analyze them, research them, and fulfill our mandate to just share helpful information with the world about deep retrofits. So today, I'm very excited to introduce you to Valentine T. Gomez from Gomex Engineering. Valentine is principal engineer at Gomex Engineering and the Maritime's only professional with all 4 Passive House accreditations. As I mentioned, we have Lorrie Rand here, president of Habit Studio and co-founder of the Recover Initiative. She has 20+ years of retrofit design experience. We have Nick McIntosh from SAIT. He is a Red Seal carpenter, a Passive House tradesperson and consultant, and a project coordinator with SAIT's Green Building Technologies. And then P.Eng, who many of you know. He is a co-founder of Retrofit Canada and a pioneer of net zero building with 45 years in high performance construction. So the Recover Initiative, I reached out to them to ask them to be our sponsor today because Valentine's case study is our first deep retrofit project from the Maritimes. And that's where the Recover Initiative is based. And I just want to give Lorrie a couple minutes to tell you about her organization. I will stop sharing, Lorrie, so you can present your slides.
Perfect. Thanks so much, Tim. And I'm really excited to be here on behalf of Recover to co-host this webinar. And I'm excited to hear about the results of Valentine's project. We've spoken about it many times while Valentine's project was well, in conception and underway. So it's really gratifying to see that he has succeeded in this amazing project. So just a few words about Recover. So Recover was born from a commitment to solve the retrofit puzzle through design, data, and deep alignment with community and climate realities. We began our story by researching energy sprung model adapted to Canadian buildings, much like, and also inspired by our friend Peter Amarongan and his team. You know, through that research, we learned that homes and buildings produced nearly 17% of Canada's greenhouse gas emissions. And so deep retrofits are essential, complex, and often just not remotely on time. And after several years of research, we were honored to be awarded with substantial federal funding through NRCan's Deep Retrofit Accelerator Initiative. And so we pivoted and grew our organization significantly. And this is a great big cliche, but we truly believe that the greenest building is the one that already exists. Our mission, our vision rather, is to deep retrofit older buildings in Atlantic Canada to be healthy, resilient, energy efficient, and environmentally responsible. And our mission is to develop deep retrofit solutions that respond to the climate crisis at speed and at scale. We serve all of Atlantic Canada, although we've also had a couple of trips outside of our region. We've done a bit of work in Ontario and also in Saskatchewan. And you know, the story here is similar to the rest of the country, but we have kind of some of the oldest building stock in the country. So we have aging buildings that are that dramatically need help. And I'm not going to read that whole thing, but what that looks like in our region is that we need to be doing 41,000 residential units per year, deep retrofits, or 2 million square meters of commercial space per year to achieve our net zero target by 2050. And PS, out of all the Atlantic provinces, PEI has an even more aggressive target aiming to achieve net zero by 2040. So Valentine's helping them get ahead of that. Deep retrofits cut emissions, they cut costs, and they improve health. And so we're working on all of on solutions that address all of these issues. And it's really important to, like, what's critical for Recover is to make sure that we're not just talking about the costs of deep retrofit, but that they actually can contribute significantly to local jobs and enhancing our property values. So Recover has many partners in this, so some of them are on the screen. Our partners in the DRE project include the Nova Scotia Community College, RFS Energy, One North End, the Union of Nova Scotia Mi'kmaq, the Building to Zero Exchange, and Navigate Energy. And the projects that we're doing under the DRE funding relate to capacity building, relationship building, project management, community engagement, and program coordination and research. I want to leave lots of time for Valentine. So if you're interested in any of this work that we're doing, please reach out and I'll explain to you, or our Recover, I'll connect you with somebody on our Recover team who can explain to you how to get involved with Recover, how we might be able to support you, and you can learn more. So the big thing that we are doing, the bulk of our funding is going to supporting research and partnerships with building owners in Atlantic Canada to actually support them to do the deep retrofits. So we have a program that in which we work directly with building owners to help them understand the technical requirements of deep retrofits and to connect them with funding in order to move forward with a project. Our research, we have really exciting research where we're contextualizing all of the building stock in Atlantic Canada so that we can present a roadmap to our provinces, showing where we can focus our efforts on deep retrofits to gain momentum. And in terms of capacity building, this is a big part of our work. We're working on education and training to tool development and engagement with communities. And we've been piloting job shadowing programs for youth to become involved in deep retrofits hands-on. We're working with building owners, industry professionals, youth, and Indigenous and racialized communities, including African Nova Scotians. Thanks.
Thank you, Lorrie.
You're welcome.
So today we will do a very short crash course in deep retrofits, courtesy our friend Nick. Valentine will present Prima and Ultima case study about the retrofit that he did on his own home, and then we will wrap up with a Q&A. So with that, I will turn this over to Nick.
Thank you, Tim. Good morning or afternoon, depending on where you are from. Like Tim said, I'm going to do a quick Deep Energy Retrofits 101 here. I got to try to move this bar so I can. I'm going to right off the bat apologize if I do end up having to kind of clear my throat or something. I have a 5-year-old that just started kindergarten, so I have kindergarten germs coursing through my veins right now. So I might have to clear my throat a little bit or take some drinks of water, just so everybody's aware. I'm going to try to mute myself if I have to do that, but I might accidentally not, and I apologize for that. So, but getting into it, Deep Energy Retrofits 101. Looking here at Canada's greenhouse gas emissions, if we're looking here, anything kind of, businesses related to buildings, so including building operations as well as manufacturing and building materials use, we're looking at about 30% of Canada's greenhouse gas emissions. So anything kind of building related, again, 30% of greenhouse gas emissions within Canada, which is quite a significant portion. So we're trying to do our best to reduce that as much as we can through retrofits of pre-existing buildings. So I wanted to show the 2021 residential energy end use for Quebec, since that is the closest that we actually have compared to the Maritimes. So if we look here, we can see we've got about 60% of the energy end use goes to space heating, 14% for water heating, and then 18% for appliances there. So a good chunk of the majority of our energy use goes to space heating. We have recently seen space cooling start to jump up as well. More people getting air conditioners put in, as well as we're getting hotter summers, longer summers as well. So if we can the thing that we're trying to combat quite heavily is how do we reduce this space heating and space cooling energy demand, and through deep energy retrofits. So there we go. So one thing we wanted to address is the 10 million building challenge. So there's 10 million buildings that essentially we have to deep energy retrofit or make net zero in order to reach our 2050 net zero goals for the country of Canada. And as Lorrie said, it's 2040 for, I think you said PEI, Lorrie? Yeah, so pretty ambitious goals. Where every year we get a little bit closer, and seems like we're still struggling to try and catch up, right? So as of now, they're between 1955 and 1990, which is kind of that nice sweet spot of houses that are ready to be deep energy retrofit and are great examples for houses that should be deep energy retrofit. There were 4 million, almost 4.2 million single detached, semi-detached, and row home units built between 1955 and 1990. So those are fantastic age homes and example homes to be deep energy retrofit, but that's still less than half the amount that we need to do for that 10 million building challenge. So getting into it, what is a deep energy retrofit? So our definition of that is changes to a building that lower its energy needs so much that it can get all its remaining power from emissions neutral sources. So how can we reduce the energy use in that building in order for us to be able to put enough solar on the roof, or if we're somehow doing wind power or something like that, can all of that electricity or that energy that we need be produced from those renewable resources for that building there. So that's making major changes to existing buildings without having to tear them down and build new in order to get our homes to that net zero level. When we're talking about changes for deep energy retrofits, what kind of changes are we talking about? A big one is improved air tightness. You'll hear a lot, one of the easiest ways and cheapest ways to actually reduce the amount of energy that you are using is by improving the air tightness of that building. So if we have a very leaky building, that heat and that comfortable relative humidity air can escape through the building out those holes of that air control layer. So we want to try to make that building as airtight as possible. Then we don't have a uncontrolled heat and air flow through the actual assemblies of the building, making sure we keep that heat, or in reverse in the summertime, making sure we keep that nice cool air in the house so that we don't have to turn on furnaces and air conditioning units as much as possible, right? So upgraded insulation or added insulation. So a couple of ways that we can do this. One of the most common ways for deep energy retrofits is to add insulation to the exterior of the existing structure. That's one that we're seeing quite a bit. We can also add insulation if we're doing a full gut renovation or something like that on the interior. We can add insulation to the interior by making walls thicker and things like that. One thing to compare it to, if in the winter time, if we're talking about exterior insulation, you put your jacket on, you zip that jacket up, you got a nice insulation layer wrapping you around, keeping you warm. An example of the stuff it method, or adding insulation into the wall assembly, is if a bear is getting ready for winter, they get nice and fat, so then they're ready to hibernate. So adding insulation to them so they don't get cold over their hibernation period. So those are just two examples I like to bring out as comparisons. And then also addressing our windows and doors. So one of the largest points of heat loss in a home is our windows and doors. So we want to try and put in nice, high quality windows that are airtight, good insulation value, try and reduce as many thermal bridges as possible. And a thermal bridge is where you have a point from interior to exterior that can carry heat through there. Windows are a very susceptible area for those thermal bridges, and we want to try to eliminate those as much as possible. So using as good quality performing windows and doors as we possibly can, right? In that photo, we have an example of a Larson Truss deep energy retrofit that happened. So that would be adding insulation to the exterior. So that is actually using dense pack cellulose, which is essentially recycled newspaper. And it's added to you still have the structure, the main 2x4 structure wall that was in that house. You build a bit of a truss type of detail on the outside, and then we filled that with dense pack cellulose. There's lots of many other different types of insulation we can use, such as wrapping it with board insulation, mineral wool, and that can all depend on certain requirements that might be there. If you have fire requirements or anything like that, you might have to use a mineral wool instead of certain other more flammable insulations. But there is many different options out there to be able to use. So it can sometimes be a little bit overwhelming, but there's lots of different options. So as I mentioned earlier, those were building envelope focused deep energy retrofits. So you'll often hear, or we will often talk about a building envelope first approach. So what that means is actually making that building as airtight as possible, that building envelope as airtight as possible, adding as much insulation as we can to make sure that we've got a good amount of insulation to prevent that heat loss. And then once we have reduced the amount of energy that is required to actually heat the home, because if we insulate well, we make everything airtight, use high quality windows, then that heat is actually staying, or that cool air stays within that house longer. So then we don't actually have to use our heating system or our cooling system as much as we used to. So then we can actually usually bring our heating system down in size. And then so with a building envelope first approach, it's reducing the amount of energy that you need in order to maintain that comfort and indoor air quality first, and then changing things to electrification that can be powered by on-site renewables. So when we're talking about electrification, upgrading and efficient heating, so currently we're very commonly in Alberta using forced air furnaces, gas gas-powered forced air furnaces. So can we switch that over to a heat pump, which is much more efficient and requires a lot less energy and is electric instead of natural gas? When we're sealing these homes up nice and airtight, we have to consider the ventilation requirements. So if we're making these houses airtight, we have to now provide fresh air instead of having uncontrolled fresh air coming in. But with providing that ventilation system, they come with excellent filters and everything like that. So we don't have to be concerned about getting dirty air coming into our house. We'll get nice clean air, consistently providing fresh air into our homes. Domestic hot water, such as a heat pump hot water tank. Switching over again in Alberta here, we have a lot of gas-powered hot water tanks. So can we switch that over to an electric hot water tank as well? And then appliances as well. So getting rid of those gas-fired appliances such as stoves, fireplaces as well. And we switch those over to electric and power those by on-site renewable energy. So once we've done all that, we've made our home nice and insulated, airtight. We've reduced the amount of reduced the amount of energy that we need, switched everything over to electric. Then we put that cherry on top with that renewable on-site energy generation, such as solar and whatnot. So we want to be able to reduce the amount of energy we're using so that we can actually power the entire building and everything within it on, for example, a solar array that can fit on the roof. I always talk about the phrase net zero ready. I always say to take that with a little bit of a grain of salt. Technically, every building in the planet is net zero ready. It just depends on, do you have enough space to actually provide enough on-site renewable energy sources to make that net zero, which most houses, you essentially have the roof space. So not a ton of space to make that net zero. So we want to reduce the amount of energy that we actually have to use. What is the result? So net zero performance. So what net zero performance means is that we are producing as much energy as we are consuming over the year. So all that energy that we need to use for our stoves, our heating, our cooling, our ventilation, we can provide that all with on-site renewables such as solar. This is going to result in minimal grid impact due to load reduction before electrification. So one problem that has been happening a little bit is if we don't have renewables on site to be able to actually do some of this powering, we're really putting some strain on the grid. So we really want to reduce that amount of energy we need and really start putting renewable sources of energy production with our buildings. So there's also many more, I don't think that's the correct, a lot more benefits of deep energy retrofits that you don't necessarily see. And this is a big thing that we need to talk about, because some of this you can't really see or quantify until you've actually been in a building that has had these high performance renovations done, and you feel it for yourself and understand it's not necessarily a quantifiable thing to be able to show anybody on a computer or anything like that. So a big benefit of deep energy retrofits is that improved occupant health. So we're getting continuous fresh air coming into the building through those ventilation systems. Like I said, we've got nice, good filters in those systems that are filtering out any indoor or outdoor contaminants, such as forest fire smoke, allergens, or anything like that. Constant fresh air being provided into the house, which then is allowing us to stay more healthy. Another thing that you don't necessarily see is that we need to maintain a comfortable relative humidity in that house as well. If we get too low relative humidity, that can dry out our sinuses, and then we can end up getting sick. And if we get too high of relative humidity and can't maintain a comfortable one, that can lead to mold growth and things like that, which can obviously affect our health. So improved occupant health is a very big benefit of high performance renovations. Improved thermal comfort. We're wrapping that entire building in nice, good insulation, and also making that airtight, which prevents cold spots within the wall assembly or anything like that. So we just have a more even temperature throughout the building. We're trying to eliminate as many cold spots in a building as possible, or not being able to use an edge of a room or something like that, because in the winter it's extremely cold 5 feet into the house from the edge of that room. So nobody wants to go sit there or anything like that, right? So another obvious one, energy savings. So if we are reducing the amount of energy that we're using, we're saving the amount of energy and costs associated with that energy as well. If we get our solar on, then our energy bills are reduced, aside from paying what we have to pay, the cost to put that solar on there. So reduced emissions. So obviously, if we're not using energy, we're not creating emissions that might be formed from energy production. So for example, in Alberta here, if we switch, even if we switch to electric, but we don't have any renewable resources, so we've switched from natural gas to the electric grid by going full electric, our electric grid in Alberta is powered predominantly by natural gas. So we're essentially switching from natural gas to natural gas, just in a different method. So if we have those on-site renewables, we are reducing the amount of emissions that we're producing there. So noise reduction, if we wrap an entire building in a bunch of insulation, we are just, and using high quality windows that are triple pane insulated frames, we're reducing the amount of noise that we have coming into the building. If I want to use an example here in Calgary, my office building I work in was built to they tried to get to passive house level, or very, very highly insulated walls. I think they're about 16 inches thick. We're on the corner of two major roads in Calgary here, and when all the windows are closed, we can't hear what's going on out on the road there. So noise reduction, it just kind of adds to that comfort level as well. Just by doing deep energy retrofits, we might be changing out certain aspects of the building that, for one, they might have needed to be changed out anyways because they were at end of life. But we're doing these changes and we're extending the life of that building. And we're also planning to try and make it more climate resilient as well. So for example, if we had to add some insulation to the exterior and we added mineral wool insulation, are we making that more climate resilient if we're in British Columbia and there's forest fires, but we've added some material to that building that is more durable against fire and smoke and things like that? We're just extending the life of that building just by doing essentially a renovation with high performance components to it. So, and then increased resale value. So obviously, just by doing renovations, even, you're increasing the resale value of that house. So by adding more and having more comfort, improved thermal comfort and energy savings and things like that, we've just increased the resale value of that home right off the bat there. So so we have found certain obstacles to deep energy retrofits taking off at a very large scale. Obviously, the big one that everybody asks about and talks about right off the bat is the upfront expenses for a full deep energy retrofit. They can be quite high. What we've seen so far is doing a deep energy retrofit to that net zero level, you're looking around $150,000 to $250,000. But when we're looking at that, there is some things that we do need to consider. So we need to consider the cost of things that were already needed maintenance. So if we were already planning to replace our heating system because our heating system was at the end of life, we had an old furnace from the 70s, we needed to replace that anyways. We need to consider that that needed to happen anyways. And what is that nominal cost of increasing, or sorry, what is that additional cost to get it to that high performance heat pump or whatnot? So there was there certain things that had to be done no matter what anyways that would have been accounted for in a renovation, and then what is the additional, that is that additional cost to do that deep energy retrofit minimal compared to the actual what you were going to do anyways. And then we need to consider the total cost of ownership as well. So we're not just looking at, oh, it's going to cost this much by the time my energy bills, how they're saying we're going to have a transfer period over at this. We need to consider that total cost of ownership and that monthly cost of ownership as well, where we have a little bit more stability because energy bills are going to go up and down. But if we don't have energy bills that we have to pay attention to because we're net zero, we have a little bit more safety month to month in terms of what we're having to pay. So we're a little bit less in danger of being affected month to month by doing these deep energy retrofits. So when we've started doing a retrofit, what we have been seeing and we want to definitely try to avoid is something we call a haphazard or a piecemeal retrofit. So this is doing half measures that you're kind of, it's okay, we changed the window, we're going to change the windows this year, not do any of the siding, then we're going to change out the siding and put some things on, but then we got to pull, or sorry, we changed the siding, but then we're going to change the windows, we got to pull a bunch of that siding off in order to change the windows. So then you're doing double duty. That just adds more cost to doing a deep energy retrofit. So these are poorly planned retrofits, and these can actually lock in the remaining emissions. So that is something that we don't want to be doing. We want to make sure that we're planning these retrofits properly. So this could also prevent a home or a building from ever becoming net zero, and that is definitely something we don't want. We would definitely be trying to get to net zero as best we can. If we do it in a little piecemeal retrofit here and there without properly planning, then we're not actually considering the house all as one. We have a definite chance of not getting to actual net zero for that home. So what we recommend is a staged approach when we're doing deep energy retrofits. This needs very careful planning though. And so it takes some time up front to make sure that we're planning this deep energy retrofit out over many years. And what we're doing doesn't end up becoming double duty in order to get there, because that's just additional money spent. Retrofits are expensive enough and difficult enough. We don't need to go backwards and spend extra money and do extra work that would be unnecessary if we took the time to plan ahead. So in this example that we have here in this photo on the right, this was a panelized retrofit that happened, I believe, in Edmonton, Peter.
Yeah.
That was in Edmonton, was it?
It was in Edmonton, yeah.
Yeah. So they put new shingles and a small solar array on 2 years before the panelized retrofit. When they did that retrofit, that roof ended up becoming redundant at that point anyways, because they ended up, I believe you added a roof on top essentially to the existing roof, correct?
That was the only way to get any decent amount of insulation. They had basically a 2x4 up there, yeah.
Yeah. So they replaced those shingles, and then 2 years later, they put a new roof on top anyways. So that if they could have waited those 2 years, would have saved all that money from having to shingle that roof there. So in order to plan for one of these phased retrofits, or even if we're going to do the retrofit all in one go, we have there's a retrofit roadmap. A retrofit roadmap that we recommend following. So before starting any work or anything like that, do a building evaluation and an energy model. So then you know where that house is at and what we need to do in order to make it the best version of that house for the 2050 goals that we have. So in that building evaluation, we're looking at, is it even a viable option to do a deep energy retrofit? If it's not, does it need to be a tear down and a rebuild type of thing? So we want to evaluate that, because we don't want to put in too much effort into deep energy retrofitting if it's a house that is going to have to come down in 10 years anyways. It's just money and effort not well spent. So we do that. That then allows us to dial in that best version of that house for 2050 in order for it to be net zero. So one thing that Peter has said is, what does this house look like in 2050, and what is the avenue for us to get there? So then we're going to map out that path to get there. What does that look like for planning? Are we going to do it in planned stages, or are we going to do it in one single go to complete that retrofit in one shot, or are we going to plan it out throughout multiple phases? And so within that roadmap, we have a few different phases that we recommend. This doesn't mean doing a phase retrofit. This is just stages or phases within that roadmap. So phase one, we're looking at that assessment phase, kind of getting an idea of the client and project profile, doing that initial assessment on that house, and then a preliminary retrofit scope, and then moving into kind of that design and contract phase, where we're doing a detailed analysis of that home, taking our time to do that planning, do that budgeting, come back. Do we need to make other changes to accommodate the budget? What does that look like moving forward? Then getting that final scope into play, and then moving into that implementation phase. So the actual construction of that deep energy retrofit. So what does that look like? Is it a phased retrofit where we have to do certain things first, then we got to wait a little bit and then do something else? So are we doing a building envelope sealing first, doing insulation, maintaining or sealing that air tightness and things like that? Then are we going to wait a couple of years, do the mechanical system and stuff like that? So one thing that we do have to consider though is thinking of the house as a system. So if we do upgrades to a building envelope and make it nice and airtight, but the home doesn't have any mechanical ventilation, there's going to be a cause and effect by doing that. So that is things that we have to consider in that planning phase for planning if we are doing a phased retrofit or a staged retrofit. So the options, there are many, many different options out there for everything that we're looking to do. Things that we need to consider. What are we using for exterior wall insulation, right? Are we able to do dense packed cellulose? Do we have to use some sort of more fire resistant insulation? What are we going to be doing for foundation insulation? What are we going to be doing for roof insulation? Can we sacrifice in certain areas, but then we have to do more work in other areas in order to get to that net zero 2050 level? Airtightness, what is the airtightness of that building currently, and how are we going to make sure that building is airtight as possible for the next level? Airtightness is can be a very difficult one in existing buildings because we're working with stuff that's already up. If it's not airtight, how are we going to make that airtightness and do those details where we transfer from airtightness on the wall to the ceiling? If we're not doing a full gut renovation and pulling everything down, that can become a problem, and how are we going to address that to try and make this building as airtight as we can? What are the mechanicals we're using? Are we switching over to a heat pump? Do we have to do a dual fuel where we have a heat pump, and then if we drop down too cold, we have to switch over to a furnace or a gas-fired furnace or something like that? There is different options and possibilities of what we can do in order to help us get to that net zero. So for an example, I'm actually doing a deep energy retrofit on my house until we can get the solar on our roof, which won't be able to happen for a couple of years at least. We are doing a dual fuel heat pump. Then if that heat pump is no longer viable, we're going to switch over to a furnace system in order to make up that deficiency if that happens. So that also comes into play in Alberta. Our electricity from the grid is much more expensive than natural gas. So if it's becoming a point where our electricity to power our heat pump is too much and it's just going to increase our energy bills, then we're having that switch over until we can get that solar on the roof there to get us to that net zero, that full net zero. So, and then electrical, what are we at the time switching over to electrical? Do we have to consider a service upgrade? Many existing homes are 100 amp service. Do we have to bump up to a 200 amp service? This is also something we want to consider in the planning stage, because depending on where you are and what the electrical connections from the grid to your house look like, it can be quite expensive. And if you are all of a sudden trying to do this deep energy retrofit and you get into that, and then all of a sudden you've got a $40,000 bill you didn't expect to be able to do a service upgrade, that's gonna inhibit the ability to do that deep energy retrofit. So, and then again, as we talked about earlier, are we doing this in steps, or are we going to be doing this all at once? And what does that look like for the planning and the actual execution of it? So we can't really say it enough, but that proper planning and design is essential to determining the optimal retrofit methods. Okay. So there is a lot of work still ongoing to help us get deep energy retrofits going at a larger scale. So Retrofit Canada and SAIT are working together to share a lot of knowledge that a lot of people in this industry have. So Retrofit Canada has a repository of retrofit information from actual completed projects. So that is on retrofitcanada.ca. Peter's at .ca or .com? .com. Retrofitcanada.com. There's a lot of case studies in there. We're still continuing to put case studies in. We've got behind the scenes lots of case studies that we have to fill out, just put all the information in and then get those up on Retrofit Canada's page. We're doing a lot of webinars similar to this one. We've got some more coming up in the future as well, featuring case studies across Canada and doing this Deep Energy Retrofit 101 initial quick little thing here. And then there is an extensive training program that we actually did develop here at SAIT, which is geared for contractors. We delivered the pilot in spring 2025. We got some good feedback. We're now kind of doing some of those iterations and changes that we got from that feedback. And I believe there is actually a delivery happening starting in November. So that course is going to be coming out as a full geared towards contractors, how to do deep energy retrofits and things like that. And then there is a lot of what we do is possible because of funding from Natural Resources Canada. So we can't thank them enough and enjoy them funding us and being able to try and get everything out here and get that training out there as well, because training is essential for both trades, designers, and everybody that's going to be involved in order to get this going at a larger scale. So that is all I have. We'll give it back to Tim.
Awesome. Thank you, Nick. So speaking of proper planning and putting together a successful project, I will turn this over to our friend Valentine to present Prima non Ultima.
Mute. Share. Sharing my wrong screen. There we go. You guys see that, or
We can see your PowerPoint interface. Can't see, I don't think we're seeing the presenting view. There we go. Looking good.
okay, perfect. Nick, that was a great presentation. I basically did everything in there, even some of the stuff that you said don't do, I also did as well. So yeah, we'll cover all of that in here. I felt like we could have combined the two presentations and just put my pictures in your presentation. Yeah, so this is a project case study, I guess, for my personal house. This is what the house looked like before we started in January of 2024. So let's, I'm cognizant of time, so let's roll right into it. Project name, you know, I named it Prima non Ultima because it's an Italian translation for first, not last, and it's my hope that, you know, this is one of P.Eng's first deep energy retrofits, and I'm hoping that it's not the last, and then we can kind of forge our way forward to getting us to that net zero by 2040 kind of thing. Located in Charlottetown, PEI. It was a single family home, 3-bedroom, 1.5 bath. It was upgraded to a 2-bath. About 120 square meters, was built in 1937. And yeah, we finished the project and moved in May of 2025. Yeah. So going right in, we had to think about what were the project priorities. This was kind of a tough decision on my end. Basically, when we came down to it, it was, do we try to push passive house? Was it embodied carbon? And then in the end, it came down to prioritizing these different sustainability criteria, because oftentimes certain things, one sustainability criteria would conflict with another sustainability criteria. And so I actually took a couple of weeks to decide the order of these priorities. And then once these priorities were ordered and determined, it made decisions significantly easier. It was just like, are we doing this? Which is the number one priority? Okay, this hits it, eliminate everything else. And so, indoor air quality ended up being the highest in our priority for this project and for my family. That isn't to say that it won't be the case for everyone else. But when considering indoor air quality, we also had to, it meant researching and speccing everything from like paints, finishes, construction adhesives, tapes, membranes. Everything was tried to have as close to zero VOC or be red list free. And for those who aren't familiar with the term red list materials, it was a term developed by the International Future Living Institute for worst in class chemicals that are mostly prevalent in the building industry. And they really shouldn't be in the industry, but they've been grandfathered in since the 60s and have now slowly, as they've tested these building materials, they've realized, hey, these shouldn't be in, so we should be looking to eliminate them from from its daily use in the building industry. So that was one of our priorities. The second was embodied carbon. The focus was with embodied carbon was twofold. So right off the bat, the biggest savings for embodied emissions was we decided not to tear down the house and build brand new. Then we also, secondly, we wanted to showcase some of the different options for low embodied carbon building materials that are out there. And the majority of the insulation in the house is cellulose. But we also ended up using hemp wool insulation, which has just recently been approved for use in Part 9 buildings, and was also fairly regionally supplied. It's manufactured in Quebec, and there was a wholesale supplier in Nova Scotia. And then we also used sheep's wool for around our windows in place of spray foam insulation. And then finally, passive house principles were brought in to help overall drop operational emissions. And kind of like what Nick had alluded to, your main principles are the super insulation, airtight construction, thermal bridge free, high quality windows and doors, and the ventilation system with heat recovery. So the initial EnerGuide results that we had done on the house basically came in at a whopping 171 gigajoules per year and an air leakage rate of 12.17. So the house, I mean, it was built in 1937. It had good bones, and a lot of these homes that are older that have good bones tend to breathe really well, because when they get wet, they have the ability to dry, and that's why they've lasted the test of time per se. But our goal, that there was comfort issues, there was the air wasn't great. I have pretty bad allergies, and even during allergy season, with our windows and doors closed, like there's still air coming in. I would still be sneezing throughout all of May, June, July, and so it wasn't great. This is a quick layout of or plan view of the first floor, and then as well. So we basically took down a lot of the walls and made it more open concept. And this is the second floor. The one thing I will note, we had renovated the bathroom in 2018, so that was actually one of the rooms that we had decided against gutting. But other than for that one bathroom, the entire house was fully gutted. Like Nick had mentioned, you want to try and have the planning in place, but at the time we didn't know we had assumed this was going to be our starter home, and then it kind of evolved to potentially now our forever home, or close to, or at least I call it that. My wife does not. For the thermal envelope, so I actually considered our basement as unconditioned and outside of the thermal envelope, and I insulated our basement ceiling and our main floor. So we had a polypropylene mesh that we'd run up along the ceiling, and then we filled the joist space cavity with dense packed cellulose. On the walls, actually this is probably a slightly better infographic, but basically going from interior to exterior, we had our drywall, our double layer strapping, our smart vapor retarder. We had added a second or another layer of 2x4s on their side to create another 3.5-inch cavity. And then the original 2x4 studs were there. We left the original 7/8-inch wood plank sheathing, and then slapped on a 5-inch Larson truss on the exterior, and then our air weather barrier, and then more strapping for a drainage cavity, ventilated drainage cavity, and then our wood siding. So as stealing from Nick's analogy here, I kind of had taken a bear and given it a jacket, because I added insulation on the interior and on the exterior as well. For the roof, it was a gambrel style roof. So part of it is our wall assembly, and then part of it's the actual roof attic. So we had about roughly 29 inches of insulation laid down. And here's a quick, so this is what was existing. And then we came in, and this is a sequencing. So we come in and we shimmed and leveled the floors and laid down plywood down. We added our 2x4s onto the walls. Then we came in with our vapor barrier and strapping, added the insulation. I will also note that this one specific point I'd flagged with my thermal cam as a thermal bridge that ran the entire portion of the main roof. And it was just due to the fact that, you know, you had your insulation going from almost 30 inches in your attic tapering down to that 3.5 inch section. And then also I needed a way to stop my dense packed cellulose from that wall section blowing up into the attic space. So we actually had to cap that with plywood. So that created a cap that 3.5 inch space. So that alone was also a bit of a thermal bridge. And then we came in with the drywall over top of that. On the exterior, on the flip side of that, we had our original roof 7/8 inch plank roof sheathing. We came over it with a Mento 3000 Connect, then slapped on 2x4s up on their side again to act as our ventilation cavity, and then went over that with a 5/8 inch plywood, and then added synthetic vapor closed membrane, and then a standing seam metal roof on top of that. Windows, we went with Enersign. They were at the time one of 2 aluminum clad windows that were Passive House cold climate certified. And it ended up being great that we went with Enersign, because I think the other company may have ended up going out of business while I was in the process of putting in my deposit. So I'm glad I didn't end up choosing that company and losing my deposit for Windows. These are some of the details for the head and jamb and sills that we went through. I will note one change here that I would have done that I didn't do, was on our sill, we were able to, or around the entire window, we were able to over insulate the window with an 1.5 inches of comfort board 80 on the exterior. We were maxed out on the 1.5 inches for the sill, but I probably could have gone to 3 inches on the head and jambs as well, because we had the space to do it, and it would have just made the window reveal a bit smaller, which would have been fine. For mechanical systems, we have a Zender Q350 ERV. There's also a Koei Air Megas 150 HEPA filtration, which we have down like near the kitchen, because my range hood actually ends up recirculating. But my HEPA filter catches the particulates that come in. So we avoided that penetration out for the vent. On the range hood, dehumidification is handled by a whole house dehumidifier, so that we pull that off the heat pump and gave that to a whole house dehumidifier. Heating's done through one Fujitsu 15,000 BTU mini split, and we did install 2 convict air electric backups. The only reason they got installed was because they were in existence before and I didn't know what to do with them, so we just put them back in. I don't foresee us using them, but they are there as a backup if we need it. And then for indoor air quality monitoring, there are 3 Airthings View Plus, 2 in the bedrooms, and then 1 on the main floor that's monitoring air quality 24/7. For domestic hot water, we kept the existing electric tank for now in our piping, and I'll talk about that on the piping side. But I did make allocation for a future heat pump hot water heater as well. We're just going to wait till this hot water tank basically reaches its end of life, and then we'll swap it out. There's also a Flow by Moen smart water meter. And mostly the reason for that is you know, from insurance claims and stuff, one of the biggest causes of damage to a house is water, and the flow meter sensor will test for leaks daily and basically shut off the water and either give me a call or send me an email and let me know that there's a leak, and they'll shut off the water automatically. The hot water lines are insulated with a 1/2-inch armor flex. There is a drain water heat recovery that's been set up for equal flow. So the drain water heat recovery feeds the cold water on the showers and also to the hot water tank. Solar shading is currently planned, but it's in the future. But it's something that we'll definitely be looking into. For appliances, there is we went with the heat pump dryer to also again avoid the penetration for the vent. The range and fridge and dishwasher are all coming in the near future. Electrical, I would have liked to have stuck to 100 amp service, but there is a future possibility of us putting in an additional accessory dwelling unit in our backyard, and if I do, it will require its own set of mechanical systems. So then at that point, it would have required an upgrade anyways. And so we decided, you know, to future-proof it, let's upgrade to the 200 amp. What we also ended up doing was we put in an exterior meter main panel with 8 circuits, and then that panel basically handled all of my exterior loads so that I didn't have penetrations for plugs, exterior plugs or exterior lighting going from the panel inside the house to all those individual circuits. We had one panel outside, and then that panel handled all the plugs and the outside lighting and everything like that. So we eliminated those penetrations as well. The bottom of that meter main panel has a pass through, so that feeds 100 amp back into the house, and then I have a 100 amp panel inside the house. So the house actually feeds off of a 100 amp panel, but we did upgrade the entire system to 200 amp. Both panels are fitted with whole home energy monitoring and data trending on each individual circuit. I'm planning on using the rest of this year to kind of commission the building with just the ERV, its utilization, the heat pump and things like that. And then I plan to start commissioning the entire house and benchmarking it in 2026. So looping back around, this was the initial Energuide results were at 171 with 12.17 for air changes, and our final Energuide results dropped to a 68 and an impressive 0.57 air changes per hour for air tightness, which I was quite pleased with. So to summarize, the annual energy consumption dropped by about 60, space heating demand dropped by about 84, and air tightness improved by about 95%. This is an interesting slide that I found recently, and I thought I'd throw this in here, but you know, it was kind of the justification for why you want to try and do a deep energy retrofit. And you know, if we're trying to have this target of 2040 and 2050, it's important to realize that, you know, sometimes yes, there is an economic break-even point, but more critical is that there's an ecological break-even point. And that ecological break-even point actually happens before the economic break-even point, which is one of the reasons why we decided to go ahead with the deep energy retrofit, right? Speaking of economics, so you know, overall, our retrofit ended up costing about roughly $350 a square foot. That doesn't include the purchase of the initial house back in 2017. Indoor air quality ended up being a bit of a premium. Embodied carbon ended up being revenue neutral when you considered the rebates from efficiency PEI. And in passive house, obviously, like the windows and doors were definitely a premium. In the end, like indoor air quality was definitely the premium, but if you can choose to put any sort of value or tangible amount to your health in your future, it this can also be easily justified. So I don't know if you can play it out in how do you define living an additional year or 20 days less in the hospital when you're 70, right? Those are all tangible things that what do you place a value on that for? So we'll quickly skim through some pictures. I purposely left most of the pictures out, but these are actual pictures that I can talk through. So when we started the demo, one of the first things we came through is we viscon the rim joist at our basement to main floor connection. Then we came through and you can actually see instead of sistering on new joists to the existing joists, we actually we lasered the floor and cut extremely long shims and sat the shims on top of the existing joists. You saved some lumber, and basically one stud was able to do 3 joists. Yeah, and then put down our membrane and then our plywood over that to protect it. And then we went down to the basement and we put up our mesh screen in the ceiling in the basement. And this is a picture on the bottom right here is the cavity looking down. So above is the Mento on the main floor, and then the bottom is the mesh screen. So all of this entire cavity got filled with dense packed cellulose. The front of the house had a bump out with 4 individual windows and an eyebrow on the top. That bump out from us living in there was during winter was perpetually freezing. You just couldn't stand there because it wasn't insulated properly. It just let cold air in all the time. So we decided to eliminate the bump out, reduce the thermal bridging, get rid of the eyebrow, and simplify the 4 windows down to one large 8-foot window that was part fixed, part operable. The other thing is that I should note with the interesting thing with our house is that there's actually there were 4 roofs on the house. So in this picture, you can see the front porch and then the main roof, and this is the back of the house. So then this is the 3rd roof is actually a roof above our kitchen, and then there's our back porch roof, which is a mono pitch out of it. So we did 3 or 4 different things on each roof because I kind of wanted to experiment with, with retrofitting and what should be done and what's easiest and what works and what doesn't work, what's time consuming. On the front porch, we ended up rebuilding the entire front porch, so we monopoly framed that. On the main roof, we ended up with a chainsaw retrofit where we ripped off, and you can see part of it, this has already been cut off on the right side. On the kitchen roof, we basically ended up keeping the existing roof as is, and then building on to like ladder blocking on along the rake, and then wrapping that with a membrane. And then on the mono pitch side, we wrapped it with the membrane and then added the ladder blocking on to extend the roof out to carry past the Larson truss. So all of them were an interesting way to do things, and there's a reason why, if you've watched enough of these webinars, people say chainsaw retrofits are the way to go. I can attest to that. It definitely is the way to go. Case in point was right here. This junction right here was just it was an interesting junction to air seal. It was tight. You really couldn't get your we used a lot of Viscon tubes just to try to get in there from the inside and the outside to try and seal that up as best as we could. Here's a view of the roof with the 2x4s, and then also when we started to move to the interior with the 2x4s attached onto the existing original 2x4s. I put this picture up here. It's our plumbing stack. So our previous, or the existing house, prior to renovation, had 3 plumbing vents or plumbing stacks going out, plus 2 chimneys. And what initially started this whole process of a renovation was that one of the chimneys was starting to leak, because the flashing had let go, and then one of the plumbing vents had started to leak because the boot that the plumber had put on was done incorrectly. So we condensed all of this, and the only penetration I now have through my roof is the 1 plumbing stack. which is unavoidable. You have to have that one penetration. And then here's us testing the different Larson trusses. So this was basically a plan view of the cleat to use for the Larson truss. We had 2 of these that we connected via studs. So I had a structural engineer basically sign off and on the design that I had come up with, and he approved it for the wind load and the heights. The cleats were 12 inches tall, and they were allowed to span 10 feet. So it worked really well that we could use 2 cleats for the entire length of our house down on both sides. So yeah, over here we had some horizontal bracing. This was actually temporary horizontal bracing. We kind of realized when we started putting these on that there was going to be a bit of a time gap between when these studs were getting put on and when the plywood was getting overlaid over them. And we didn't want any of these studs bowing or warping in the sun as they dried out. And so basically we ran these horizontal L brackets along just to kind of tie them and stiffen them so that they wouldn't warp on us and then as we went to go put the plywood on, we took the bracing off and put the plywood up. This is our front porch, getting insulated with hemp wool from the interior. You can see that we did frame it up here, and Monopoly framed it as well. The bottom of the Larson trusses were capped with more 5/8 inch plywood, and then we taped that connection with one 12-inch wide tape that went down to the concrete as well. The other thing I wanted to chat about more is these strips of polypropylene mesh. So this is also one of the, I guess, lessons learned. There's only one company on the island that does dense pack cellulose. When I had them out to look at essentially this setup, they were a bit uneasy. They'd never done anything like this, and so they came in and they said, we request that you actually close off all of your Larson trusses. They were like, just take some plywood or some studs and close those off. And I was like, that's going to completely negate the whole point of the thermal bridging and the Larson truss. And so we kind of went back and forth. And then in the end, I basically said, look, I'll hang up these polypropylene meshes. I'll staple them so that they create their own cavity between the Larson, between each Larson truss. And I said I'd take the time to do that if they would basically do a field test and see if it was actually required. So they said they agreed to it. They said they would come test a certain portion of our wall, but they couldn't come for 2 weeks. So I didn't want to have any further delay, so I just went ahead and started putting up these polypropylene meshes on every Larson truss. But then we actually left a portion of our front porch, the left side of it or the right side, depending on how you're looking at it. We left one portion of our front porch without the polypropylene mesh, and they came in and tested it. So this is the mesh that I had stapled on. It took forever to do. It was not something that I was very keen on, but I wanted to know if this was a requirement. They were worried about the cellulose flowing between the trusses, between the spaces, and them being able to get to their actual density that was required if it continuously kept flowing from one truss and around the corner and stuff like that. So, they came in, and it was actually this face right here that we ended up not putting any mesh screen up. You can see I have the mesh there, but they're not there. And when we also wrapped it around the corner as well to test to see if it would come through a corner. In the end, the cellulose flowed essentially like water. It found holes that I hadn't taped yet that were 1/8 inch that we had to stop them from filling in the dense pack cellulose. And I had to go in, clean up the stud, tape it, and then they could continue again because it was flowing through the tiniest of holes. So it was a good lesson learned that mesh separation or that separation is not an issue. Actually, you can fill that hole cavity. It was just a learning curve that the insulation company needed to go through, and now that they've done it, they're a little bit more comfortable doing it going forward. So we obviously then started sheeting the entire house, and then started adding the plywood bucks in for all the windows, and then quickly switched to the Adiro on the walls. So as soon as I had our Adiro up, I ran a blower door test and a smoke test. 2 minutes into the blower door test with positively pressurizing the house, we completely lost pressure and we were wondering what was going on. We walked around the house and we had actually blown out one of the plywood windows when we were testing the house. So that was a very good sign. We had to repair the window and then go back to the test. The other thing was we had rented a fog machine, and this was great because up on the roof, the Mento 3000 Connect, I believe one of my carpenters, when they ran it through and pulled the tape or the Connect, they didn't actually press fix it, and so we were getting smoke leaking from that entire seam. So as a belts and suspenders approach, we did go through and press fix that entire seam, but then we went back and taped the entire seam as well, because once we plywooded over, we'd never have access to that. So if it was going to leak, I didn't want to not have something that I couldn't access and solve. So then moving in to the interior, this is the main floor. So I'll point out here this is our roof joist, or not the second floor joists that we ended up framing as well, and you'll see why here in a second. But as we brought our vapor barrier up, we actually taped up into that cavity, and that was also to hold back some of the cellulose and also provide some sort of a better air seal. It wasn't continuous because up on the second floor, we connected that to our new plywood. So there was a tiny gap there, but in retrofits, your interior vapor barrier is not your primary air barrier, it's your exterior. So this is the upstairs floor before it received its second layer of strapping. And this is the cellulose going in on the inside and the outside. Then the strapping. And we moved on to putting in our taped sills on all our windows. The windows then did get stuffed, as I mentioned, with sheep's wool, and then we used Tescon Vanna tape on the interior and the Contiga on the exterior as well. So we've heard of over insulating your frame on the exterior, but we ended up, when we put the drywall in, we ended up having an additional cavity there that was open. So and I had additional sheep's wool, so we over insulated the frame behind the drywall on the interior as well. This is us putting in our back door with our sealant on top of our sill. And then our ERV install, basically we had one mechanical chase that was in the middle. That mechanical chase did triple duty because it acted as the chase for all of our ductwork. So that's my silencer, and then also the filter box for the ERV. If there's ever fire smoke that comes up to Charlottetown from forest fires, I have the ability to add an additional HEPA filter on top of the filters that are already there to take out any forest fire smoke, and there's an activated carbon as well to take out any smoke. The chase also acted as along the bottom here is where we had every single one of my electrical penetrations that were going down to the panel in the basement. And then at third duty, it also acted as our IT room for all of our IT stuff. So this is all of every single wire going down to every panel came basically met back to this chase and then went down. This is the piping manifold for our hot water. So I went with instead of a trunken branch, I went with a manifold setup with 3/8 inch lines for all of our hot water where it was needed. And then that's the Moen, the smart water meter on the right. And this is our final smoke test and blower door when we were coming through, along with checking for any sort of thermographic cams. And yeah, these are some finished, unfinished products at the end here. You know, at the end of the day, I can't really stress enough the importance of, like Nick had said, the importance of planning. Planning was so critical in this stuff. There was a lot of times where my carpenters would kind of just laugh at me because I'd be standing at a corner and looking at a wall for 45 minutes. Be like, what are you doing? And then 2 weeks later, they'd be like, hey, we got this problem. And I'd say, this is the solution. And it was nice and elegant the way it rolled out that way, but it was due to a lot of planning. Yeah. Are there any questions?
Thank you, Valentine. That was awesome. Again, Retrofit Canada is so grateful that you took time to build out a case study with us. That's available on retrofitcanada.com/case studies. And also just the time you put into this presentation. Very detailed, got into the technical aspects of the retrofit, which is what we want. So for the Q&A, if you can stop sharing your screen,
Oh, yeah.
would be awesome.
There we go.
Lorrie and Peter are going to get us started with some technical questions. We are a little bit behind today getting to the Q&A, Lorrie and Peter, so I'd like you both to just pick one question to ask Valentine, because I really want to get to the questions from our participants. So Lorrie, I will start with you.
Thanks, Valentine. That was really great. And bravo for going through so much information. And, I know we're a bit over time, but that was a pretty short amount of time to tell us about this project. I just want to go way back to the beginning and thinking about the house as it was. And could you talk just a little bit about was this house ideal for this kind of retrofit? If somebody was looking at a property and considering doing something similar, what they should look for, and was there anything that was really, really hard about this property that that made the approach challenging?
So yeah, yes, the house was an excellent candidate for a retrofit, in the sense that the bones were really good. So the structure in itself was, the main structure was in excellent shape. I think we had replaced one floor joist that we had found was rotted, and that was from that plumbing stack that was leaking, which is a testament to how much water damage can do in such a short amount of time. But other than for that one joist, everything else was in excellent shape. So usually when you tear apart an old window, everything under the window is completely destroyed and has to be replaced and redone. We didn't run into any of those issues with that. So it was good on that aspect. The other side that was a bit of a challenge was the houses in downtown Charlottetown, our lot sizes are not very big, which is what actually forced my hand into doing the bare with a jacket type of insulation, because I couldn't insulate my exterior to the extent that I wanted to, because we have a driveway and then my neighbor's house is built on the property line. And so ironically enough, what dictated the 5 inches Larson truss was we actually took my carpenter's minivan. And I was like, if there's ever a point in time that I end up having to buy a minivan, I need to be able to fit it in here. And we parked it in our driveway and then we measured out. That's what delineated how much insulation I could put on the exterior without actually losing my driveway. And then I added on the difference with the interior insulation to get what I needed. So it was just an
So-
interesting challenge, but yeah, it just required some outside the box thinking. That's all.
Thanks, Valentine. Peter.
I have a million questions. But I think if I only get one, the one I want to ask is, you insulated on the inside and the outside. And what were the things that made you do that rather than just doing it on the outside and making your Larson trusses deeper?
But yeah, so that was what I was just noted with Lori's question there, was because our lot size was so small and my neighbor's house was directly on my property line.
I'm sorry, yeah.
The driveway, part of the city bylaws is that with any renovation, you can't eliminate your driveway. You need to still have parking access. And so that was what dictated the fact that my Larson truss could only go 5 inches. Any bigger, and I physically wouldn't have been able to fit a minivan in and open a door.
Okay, yeah, that was a big price to pay.
Thanks, Peter. Okay, we're going to turn this over to our participants, and I'm just going to start at the top with our questions and work my way to the bottom. The first one is for you, Lorrie. The Recover Initiative is a nonprofit serving Atlantic Canada. Do you collaborate with other similar nonprofits elsewhere in the country or in the US? And do you foresee Recover extending beyond Atlantic Canada eventually?
So I do not currently.
Oh, Valentine, that one was for Lorrie.
Oh,
No worries.
go ahead, Lori. I was like, geez, this is a very tough question for me to answer.
Recover does collaborate with other organizations, some for-profit, some non-profit, some academic. And we were doing that, like even before we received the DRE. So there's actually a network of organizations that received the Deep Retrofit Accelerator funding. So we collaborate a bit with them. And, I feel like this question is like, you're secretly on our Miro board where Recover takes over the world, right? Anyway, yes, always open to partnerships. We think that, partners make us stronger. So that's
Thanks,
that.
Lorrie. We got this question from Kevin Brown. I'm actually going to take a crack at answering it, and then everybody else can tell me if I'm wrong on the panel here. Kevin's asking, does anybody know how many deep energy retrofits are happening in Canada per year? I'm going to say that it is probably around dozens and less than hundreds. Does that feel right to our experts? That is just based on what I know in terms of the builders and homeowners that we are aware of.
So when we started Recover, we referenced some statistics that were published in a report by Ralph Torrey and Brendan Haley called Canada's Retrofit Mission. And they said that around 0.7% of Canada's building stock was being retrofitted annually at that point. More recent numbers, and I don't remember where this number is from, but it's slightly over 1 now, like over the 3 or 4 years since that report was published. It's grown a little bit, but we're nowhere near. That report actually said that we needed to, if we started in the year it was written, maybe 2021, if we did 5% of the buildings every year, we would get to our target by 2050. If we waited 5 years, I think that number went up to 12%. So we're closing in on needing to retrofit 12% of our building stock annually if we're going to meet our climate goals, which is scary, but that's what we're all here to do. So
I also feel that the definition of retrofit has evolved over the years, and like the initial loose definition was like, anything that improved your energy consumption 50%. And I got into a discussion with an architect once, and he was like, well, I had a building that had no insulation, and then I put in an inch of insulation, and it improved its it dropped its energy use 50%. I was like, well, it's still horrendous. I wouldn't classify that as the deep energy retrofit. And he was like, well, it improved it 50%. And I was like, okay. So like, I think now that there's a more clear definition on what a deep energy retrofit is, or it, that alone is basically eliminating some of the deep retrofits just by via the definition.
Thank you. Our next questions, and actually, I think there's 3 or 4 or 5 in this from Natasha Denenhauer. We're only going to get to one, Natasha, because I want to keep going through the other questions we have. But she is asking whether or not any of us on the panel here are thinking about embodied carbon and comparing and contrasting the impact of those numbers with reduced operational emissions. And Valentine, I know that you have spent a lot of time thinking about this, so I'll let you start.
So yes, so I'm actually working with UPI, where our project is going to be put up on a case study and compared with embodied carbon versus a brand new code built house, and then also versus an R2000 house. And so they're essentially going to compare the embodied carbon savings or the embodied carbon emissions from all 3 houses, and then try and present that to the government, because that master's student was funded through a climate challenge fund, which the province of P.Eng gives funding for every year. And so that data will be done. I'm also looking at, if I have some free time, at adding this project into the Beam case study database as well, which is their embodied carbon. I'm hoping the master's student will take some time to do that as well. But yeah, well, obviously I have a generic rough idea of where my house will stand compared to a code built house and an R2000 house that was completely spray foamed.
Awesome. Peter, any thoughts on this?
No, I thought that Valentine's comments were pretty good there. So
yeah. Lorrie, I know I've seen some of the feasibility studies that are the Recover Initiative, and embodied carbon is for sure one of the main topics.
Yeah, we modeled, I mean, our interest was in adapting energy sprung to North America using low embodied carbon approach. So all of our studies looked at the viability of that on specific building types. And now that we are kind of in Recover 2.0, we are asking anyone who's working on projects with us to report on the embodied carbon. Say if we've commissioned feasibility study about a deep retrofit to a building, we will include in the scope of work that they need to tell us about the embodied carbon of whatever solutions they're proposing. Where some of the project is focused, the DRE funding is focused primarily on Part 3 buildings, so not all of them are suitable for just whacking fat walls with cellulose, but that's certainly we're aiming to level up the industry standard in terms of what is done on retrofits in our region in terms of the carbon footprint.
Awesome. I can say from our experience managing the case study library, I have 35 to 50 case studies. We got a bunch in the works, and we have 36 published. And I think I got embodied carbon for a couple. And I also have some feasibility studies from Recover in there that do talk about it. But the fact is that Valentine, what he just described, is exactly what needs to happen to get the embodied carbon numbers. Is you have to have a intrepid master's student attached to a project who's going to be doing this work. And most homeowners, contractors do not have that kind of resource. So we had operational carbon numbers. Those are easier to get. You can calculate those based on the building performance and the improvements you make, but the embodied carbon is much more difficult.
I will say, anybody can put like a single family home in the beam calculator in a couple hours. It is not complicated. It's very user friendly.
I'd also like to add that, one of the things that's encouraging that is how fast the awareness of the consequences of high embodied carbon materials is permeating the building industry and the architectural and engineering community. I really, it's so existential. I think it really is sinking in fast, and it may not be getting down to the small contractor level very quickly, but I think it's pretty hopeful. And secondarily, when you're reusing an existing building, you're already so far ahead that I don't think it's critical to be aware of the impact of these materials, but I don't think that we need to be too anal about keeping track of the numbers. I think we can take a kind of a looser approach to it. And as Lorrie says, it's not hard to do.
So I'll add to that and say I have sat on some of the National Building Code meetings, and the plan currently is for embodied carbon targets to be introduced into the National Building Code starting in 2030. So if you're doing it now, great, you'll be ahead of the curve. But if not, it's coming.
Okay, this next question was, have we come across any houses that manage full electrification on just 100 amp service? I know the answer to this is yes, but I'll let our experts respond.
So do you guys know the who runs Passive House Alberta? I'm trying to remember his name.
Are you thinking of Frank Crawford?
That's it. Yeah. Frank put together an excellent presentation on houses that on how you can go about doing a deep energy retrofit and staying at 100 amp service. It was great, like even including things like where you can share load share with using load share devices. So basically your EV charger load shares with your dryer, and you have your dryer set up as your primary. So if you ever need to use your dryer, it's there. It just stops charging your EV for that little bit of time. And then as soon as your dryer is done, you go back to charging your EV. And so it's by load sharing that same current draw that you can get away with staying on 100 amp. And that's typically what I would try and do if you were staying as a single family home. You would try and push that.
Yeah, I think it's getting to be easier and easier. And one of the projects in our case study library is a 1,200 square foot bungalow in Edmonton, so climate zone 7A. That it had 100 amp service underground. It was going to be very difficult to upgrade, and they went through the -40 period with their toss out heat pump, and we're toasty through the whole period with so basically no backup heater, just the heat pump alone. And I think that's doable with the right heat pump and the right envelope upgrade. But it also, this necessity to stay on 100 amp service, which when I say necessity, I mean it. Collectively, we can't afford to retrofit all our houses and increase the service sizes. The costs will be in the many, many billions. I think it's doable, and it needs to become one of the main design parameters in working out the solution for any particular building.
Peter, which case study were you referring to there? Was that Hoffman?
That was Hoffman, yeah. And we're doing it at our house, Zoo House is doing a number that are staying on 100 amp service that'll not in the library yet, but they're on the way.
Yeah, and I mean, even more and more appliances that used to be big draws like are now like a simple 110, like the heat pump dryers now that they're coming out with, they're 110, like 15 amp. The electric hot water heater, the heat pump hot water heaters, they're now coming out with them. Those are also like 110 volt, like maybe 20 amp. Like
15 amp, 50. I'm sitting here looking at one. It's getting hooked up to the water tomorrow. Our retrofit, our duplex retrofit, we're putting in two of them, one on each side that are 15 amp. 15 amp 240, but still it's very helpful not to have that great big breaker.
yeah, exactly. And those are some of the things that will go a long way in helping you stay at 100 amps, right?
Okay, our next question, Valentine. This one's from Kevin Brown. Did you run a thermal bridging model on the wall to roof joint?
No, I didn't. I haven't had time to do a lot of thermal modeling. I did go through with my thermographic cam, and that's where I had noted that uh, it was colder. I'm gonna still continue to monitor it, but I haven't seen any uh, any issues from it so far because I'm running whole house dehumidification as well, so I'm controlling the humidity in the house quite carefully, I should say.
This one's kind of a more general question from Fraser Dow. After a retrofit, can you sell the property easily, or did you spend so much that it's a long-term investment just for personal homes? So Fraser, I've talked to dozens of homeowners about this, and you hear two or three things all the time. One is that was very expensive and complicated and a lot of work, and I would never want to go through that again. For sure, I hear that all the time. The second thing is I would never ever go back to living in a code-built house because it is so much better. Like they are ecstatic about their investment. And then the third thing I'll say is that I do know that some properties retrofits have sold after they were completed and they went for a higher price. Again, that is so specific to your real estate market, wherever you're trying to do it. And I think it has more to do with that. I believe that mortgage lenders, real estate agents, and all of us in the movement need to figure out a way to start promoting the value of retrofits, because there is for sure a value that you could put on them that would relate to the value of the home. I don't think that's happening as much as it should be at this point. Even in Edmonton, I was talking to my real estate agent. I was like, why don't we have solar panels as a box you can tick when you're looking for a house? She's like, I will see if we can get that added. And she tried and they didn't. So anyway, any other comments from Peter, Lorrie, or Valentine?
Well, I kind of want to just comment on that. I mean, Valentine, your 350 a square foot probably includes a bit of sweat equity on your part, but still, like what we're finding is that like retrofits that include great performance targets don't cost very much more than kind of code minimum gut retrofits that we're seeing in our market. And really it's a few extra dollars, but it's mostly better planning and prioritization of how you're spending the money. A lot of people buy a house and do a renovation and it doesn't do the smart things. And so there's a bit of a culture of shift, I think, needed to understand that actually, like what looks like crazy amount of insulation isn't, and that you can get both for close to the same amount of money.
Yeah, I will say, like, I'll speak for PEI specifically. Like valuations currently do not account for anything even close to high performance. Where it should. They typically go off of, oh, you have a 3-bedroom, 2-bath. Like, let's find the closest 3-bedroom, 2-bath that is sold in your area in the last 6 months, and then they kind of evaluate based off that. I mean, they do take into account certain things, but I personally think one of the policy changes that I know PEI currently is trying to push through, I don't know what status of success they are at right now, is mandatory enter guide labeling, which I think will be huge for improving resale values on houses because you know at the end of the day, if you have 2 identical houses and one has enter guide rating of 280 and they're the exact same size and the other one's like 42, why would you ever buy if it's in the same area and the same size, like why would you ever buy the one that is way less energy efficient? So inherently that one's going to get dropped in value and then the other one's going to get upped in value as well. So yeah.
Yeah, and I think that extreme weather, like the extreme heat waves we've been seeing, major cold snaps, other examples of extreme weather, I think are going to make people realize the value of better built homes, houses, and buildings that have just been made better through retrofit. I also think that insurance companies are going to start requiring some of these upgrades and make houses more climate resilient, and that will really put a little bit of a dent in people realizing that this stuff is actually worth
I,
more than the granite countertops.
Yeah, I'd actually reached out to our local insurance provider here and, I chatted with them about, potentially offering their clients with high performance houses, a discount per se on their insurance. And, he got back to me and said, we recognize the value of passive houses and deep energy retrofits, but he was like, unfortunately, we don't have the data behind it to back it. And so they were like, we see it, it's coming, but like we just don't have the data. The insurance industry is all numbers based and actuaries, right? So they have to have the data to back all that stuff before they can solidify and say yes for sure. So they need more houses basically providing this data, proving its resiliency and going from there.
Thanks, Valentine. This one's simple. Question for you, Valentine. What company was the wholesaler in Nova Scotia for the Quebec-made hemp wool?
So Nature's Fiber is the manufacturer in Quebec, and I believe it's Atlantic Hemp in Nova Scotia. They're like close to Pictou, so northern, close to the ferry.
Another one for you, Valentine. Do you know how much time you spent during the planning phase?
Oh,
We'll take weeks, months, year, and nanoseconds.
I mean, you have to keep in mind, I also had a newborn that came in right in we started our renovation in January and we had a kid in our second daughter in March. So, planning was in between all of that. It was just 24/7, going through it. I say that, but I've owned the house since 2017. So in theory, I've been planning this in stages like for a very long time. It's just we didn't execute this for until now, right?
Yeah.
It's kind of hard to just tag a set number because there was a lot of research, a lot of research attached, but then a lot of the time consuming part was the indoor air quality, like trying to find building materials that are red list free, looking through the ingredients of like virtually everything and anything that came into our house. So I didn't allow my guys to have any PL premium. There was no PL premium because it off gases formaldehyde. So I brought in a formaldehyde free construction adhesive that my trades were like, why doesn't everyone use this if it's better for us? Because it off gases the most amount of formaldehyde right when it's applied. So it's the trades who are applying it where it affects them the most. but I told them, like, you know, so it was researching all of that stuff that takes the time, right? Like, and a lot of that whole industry is shifting very quickly. So
Yeah.
you kind of have to stay on top of it.
So another one from Kevin Brown. He's wondering if you could share the engineering report for the Larson trusses. Not, we don't have to do it right now, but if you have it, we could add it to our
Yeah, Kevin, reach out to me and I'll see if I can send you what they sent me.
And if you share something with Kevin, I also want it, Valentine.
I mean, yeah, it was 3 5/8" GRKs per cleat. The cleat had to be 12 inches long, and it had to be a 3/4 inch plywood. And I think we did 4 nails from the plywood into the cleat, into the 12-inch stub, and then 4 more nails from the plywood to the actual 10-foot span stud.
Mhm.
But yeah, if you send me an email, Kevin, yeah, that's not and I can send it to you too, Tim.
I want it. Okay, I guess for the panel, maybe I'll start with Peter Amarangan with this one, but from your experience, what's the ideal amount of exterior insulation if you want to, if you're not aiming to reach passive level performance?
You know, it's going to vary by climate zone, obviously, and by what you've got already. But you know, somewhere around R20, I think, will get you through. You know, we'll hit the knee of the curve in most places, but it also has to be, because you have to consider the building science as well, whether that's going to keep the assembly dry and safe. So there are a number of considerations, but if I just had to spitball a number, I'd say it's somewhere between R20, R25.
Anybody want to fight with Peter on that on the panel here?
I don't even know how to answer it. Broke my brain. I mean, I energy model almost every project that comes in our door, just to, like, not necessarily to achieve passive house, but like you want to know where the point of diminishing returns is, so that you kind of like feel like money's not being wasted by going outside. But the other side of that is also how airtight is it? Because it's really pretty pointless to worry about insulation if you're not equally leveling up your airtightness. So, you know, there's really, they go hand in hand. And so if I'm looking at a retrofit, I'm kind of like, what's viable here in terms of achieving airtightness? I might add more insulation if it's like a really, you know, if it looks like a Disney castle and the airtightness doesn't, you know, achieving a high level of airtightness doesn't seem super viable. So it really is a, sorry, it depends kind of answer. But more is better.
Awesome. Valentine from Aaron Smith, did you consider humidification, or was this not required with your air tightness and humidity recovery?
So, yeah, I that's why I have a whole house dehumidifier. The ERV actually, counterintuitively to what some people often think, the ERV actually works to increase humidity levels in your house, because it's for in winter, not decrease it. But so the dehumidifier acts in to actually control the humidity in summer, and then the ERV will take over more of that load in the winter. So I'll lean on the ERV in the winter, and then I'll lean on the dehumidifier, the whole house dehumidifier in the summer. And the whole point of the whole house dehumidifier was mostly was to pull the dehumidification load away from my heat pump, because typically when you run your heat pump, its main priority is to cool, and it will dehumidify while it's cooling, but as soon as it reaches its set point, it'll shut down on a temperature level. It doesn't care what the humidity's at. And so you don't really get successful dehumidification. But if you have something that is doing dedicated dehumidification work, then your heat pump doesn't need to do that. It doesn't need to worry about that. It's more efficient at reducing the temperature versus dehumidification. And so the two together tend to work a little bit better, and both end up being a little bit more efficient from it.
Thank you, Valentine. And one last question for you. Did you get the Interfit certification for this project?
I was going to note this at the beginning of the presentation. I was going to provide some backstory on why I didn't get Interfit certified. And when we started this renovation in January of 2024, we actually never planned for this to be a deep energy retrofit. It was never intended to go this far. We had that one leaking chimney and the one leaking plumbing vent, and we were expecting a baby in March. And so we had said, let's just move out for 2 months and renovate the upstairs, take out that chimney, and then fix the plumbing leak. And we would fix the upstairs to basically how it was done now, how it was planned, but we wouldn't have done the entire house, just so we weren't repeating things. And then right before, I think like middle of February, we were like, what are we thinking? Like, this is so much work. We're planning on moving back into our house only in a few more years to try and move back out again now with 2 kids. And one of them's entering school, so it'd be harder. Plus, cost of construction was going to be more expensive. So then it was just like okay, let's bite the bullet and do the entire house. So then we scrambled, and so at that point, I was against the gun with timing, and certification would have added to the overall timing, and so we opted not to certify. But I think I have enough pictures that I've taken of the entire project that I could potentially go through and get certified if I have the time.
Thank you. So that was our last question. I want to thank Lorrie, Valentine, Peter, and Nick, who had to leave to go to another commitment. But thank you all for joining us today. That was awesome. We went almost half an hour over what we normally budget for these, and the majority of our attendees stuck around for the Q&A. Just awesome. This is really important information. They're invaluable conversations. So thank you all for answering the questions and taking time to stay here a bit longer. Retrofit Canada appreciates it. To the rest of you, I invite you to connect with Retrofit Canada, your website, retrofitcanada.com. We're also on LinkedIn, Blue Sky, Instagram, that other one, YouTube, and Facebook. Find us there and help us get the word out. We'd really appreciate that. And otherwise, thanks to all of you for attending and participating. Have a great day.
Thanks, guys.
Thanks,
Thanks
Tim.
all.
Thanks, everybody.